Okay, in this tutorial, we want to know if the following integral converges or diverges, and if it converges, we want to find the value. So the first thing we're going to say is that t is going to approach 2. This is because we know if we have a value approaching 1.999, we'll get infinity. Likewise for 2.001, we'll also get infinity. That's why it's a good indicator that we should define that value as a variable. So what we're going to have now is going to be 0 to t. We can say x minus 2 raised to the negative fifth dx. This is just helpful to take the antiderivative. So now we take the antiderivative. So negative 5 plus 1 is negative 4 divided by negative 4. So we'll get negative 1 divided by 4, parentheses x minus 2 raised to the negative 4, and we're plugging in 0 to t. So this right here is equivalent to negative 1 divided by 4 x minus 2 raised to the fourth. It's simply equivalent, and we're going to plug in 0 to t. And so by doing that, we will get negative 1 divided by 4 t minus 2 raised to the fourth minus so positive 1 divided by 4 negative 2 raised to the fourth, same thing anyways. And so this is what we have. But now we need to consider the limit. If one side approaches infinity, we can conclude that it diverges. So we first try 2 to the left, and we see what happens. And so what we're going to get by doing that is negative 1 divided by 4 t minus 2 raised to the 4th. So we need to look at this. So if we have 2 to the left, so that means 1.999. So we have essentially right here 0.0001 repeat, and we're gonna raise it to the 4th. This means that this is a very, very small number. So we have negative 1 divided by a very, very small number. Therefore, this in itself would be negative infinity. So we can conclude that it diverges. I mean, we don't even need to bother with this, since this would be 1 over 64, and we know that this is negative infinity. That's more than enough. So that's how we can conclude that this integral would diverge.